Good afternoon everybody, my name is Mark Fort from Edge PLM Software Proprietary Limited, and we'll be covering what's new in Solid Edge ST8 in this 2-week webinar series. Solid Edge, as we all know, is from Siemens, and Siemens is a global leader in manufacturing and has been for the past 160 plus years. Siemens understands and addresses the challenges that we all face in engineering today. Siemens Solid Edge and FEMAP covers the whole gambit from design through simulation, manufacturing, design data management and applications. This new area provides third-party and Siemens applications on a website. We'll take a look at that a little later. Siemens PLM software solves the engineering challenges that we face every day. As I said, this seminar series is about Solid Edge ST8 and what's new. And the theme is Designing Without Boundaries. Today's agenda, we're going to cover the new features that are launched with ST8, the areas of pattern recognition, design intent, helical curve, pattern by table, and the new productivity tools in assembly. We'll follow that up with a Q&A session at the end. If you type your questions into the comments box on your interface, on your web interface, we'll address those questions as we come to the end. Designing without boundaries. ST8 delivers a uniquely powerful and accessible 3D design portfolio. This is about providing a design environment that allows you to do your design work without the CAD system getting in the road. We'll look at the uniquely powerful new features that are provided with Solid Edge. We'll look at the accessibility that Solid Edge provides and the user experience. Starting off with the new powerful features. Okay, let's take a look at some of these new features in Solid Edge ST8. The first we're going to look at is Like Me pattern recognition. And what this allows us to do is to recognize faces and create patterns or pattern features from completely dumb geometry. There's several cases which could use this, so let's take a look. Here we want to make some changes to this gripper arm assembly here, so we'll just delve into the sub-assembly here. Very pretty. And I want to take a look down at the detail there. Let's just open that up. Take the lid off, and we'll see we've got a couple of gripper arms there with gear teeth on them. They've got 12 teeth on those teeth. And what we're doing is we're going to be making some changes to this assembly. We've got a different gripper arm that we want to fit to it, but that gripper arm has come in from a different CAD system. Let's just go and find that. It's not a Solid Edge part file, it's under all documents. It's a step file, and then we have a step file. What we're going to do is just translate that into Solid Edge very quickly. And here we have that step file translated to Solid Edge. And what we've got is, it's all very nice, but it's completely featureless. It's just a group of faces. And it would be nice if we could modify some of these features in a procedural fashion. What I mean by that is we've got obviously some sort of pattern here that was used originally to create these teeth. Might be a pattern here as well. It'd be lovely if we could recreate that. Well, we can. Under our pattern command, which has been there for a long time, brought in an ST7 recognize whole patterns. We can now recognize more complex patterns. And in this case, what we want to do is recognize this set of teeth as a pattern. All we have to do is select the faces that will make up that pattern, right-click to accept that, and it generates a pattern. It's generated a circular pattern by finding similar teeth, or similar groups of faces, more correctly. So we've found a center, we've found the pattern circle, and so on. Again, we might want to do the same thing up here with these features. So exactly the same process. Under our pattern, recognize pattern, this time I'm just going to do a group select, that area there, right click, and it's found a linear pattern. Say OK to that. Okay, let's make some changes to those patterns. We had before 12 teeth, or a 12 tooth, wasn't 12 teeth, it was 12 tooth pitch, and that's a 10 tooth pitch, and I want to change that to 12. You'll notice also up in my command bar all the other pattern controls are available. This is a procedural feature. In other words, it's a synchronous feature, but it has a procedure behind it that allows us to modify it. Let's make that change. It's done that very nicely. This one here, again, we want to make some changes to that. We get the same set of controls back as we've always had available. We want to make, let's say, 10 in there will do. So now we've got a nice fine grip pattern. We'll simply save that and return to our assembly. Now, as I said, we want to make those changes, so all I have to do is replace those parts. Replace part, replace this one with the one we've just created. That's our left one. Because we've got assembly constraints on there, we'll suppress those for the moment and clean those up later. Let's make a change to this one. Again, we can select the object before selecting the command, and that's going to be the right hand one. And there we go. We've got a new assembly. Let's just return to our next level, our previous level, and we've got our assembly displayed. We've got the new grippers on there. Something that's changed recently, we've got a drop shadow. Just let's go back to that assembly for a second. Open that assembly, that sub-assembly, and turn the floor reflection off. We've got a drop shadow, which we've had for some time. But if I stand that up, you'll notice we've still got a plane to drop the shadow on, which is just a nice little enhancement that makes things look a little bit better. So we saw with the pattern recognition the capability of it's an enhanced facility to recognize groups of or sets of faces and create patterns for those, whether they be linear or circular patterns. You can run it multiple times on a part. There's no limitation to that, of course. You can use it both with imported parts and existing solid edge parts. You might have created what effectively is a pattern using a sketch, but you'd like to have a pattern control over that later on. Well, we can do that. And this extends the reuse and editability of both existing and imported parts. Great comment from Philips Medical. Synchronous technology in solid edge greatly facilitates data reuse while avoiding costly redesign. Improvements to synchronous design and tent management enables you to focus on your designs and less on the tool, resulting in accelerated modelling process and shorter time to market. Okay, let's have a look at this in some detail. I've got a part here, an interface adapter, that we want to edit and create some geometry on. Let's just zoom up a little bit. If I select this face and the synchronous part to make some modifications, what we see immediately is the new design intent relationship dialog box pop up. As we move the face, it shows us what design intent constraints it finds within the geometry. It says that there's a symmetric constraint and coplanar. I don't want the coplanar, so I'm just going to turn that off. So I just select it there, and I'm just moving that face. But let's have a look at what else is available here. Click on the question mark. It brings up our in-context help. In this case, I'm just going out to the internet to get it. You can set up for local. And we can also set up to view a video. Now, it has sound. I'll turn the sound off. And it has closed captions. Either way, you can get a great deal of information from this. Quite a number of commands within Solid Edge have this facility, so it's worth taking a look at. Okay, what we want to do is just pull this all the way through, and I want to create a cutout in here too. So what we're going to do is use my pop-up menu to get a circle to draw on here, lock onto the plane, just find the center. It's there, just out to here will do. We know with Solid Edge, with Synchronous design, we can extrude and cut. Quite straightforward. Again, applying features to design. I want to put some rounds on there, just little 1/2 millimeter rounds. It's as good as gold. Let's look at something else that's changed a little bit here. I'll just zoom in a little bit further and get what I want to select. There we go. Just want to select all the faces on that little block there. As we move that block, by default, just the block itself will move. All those features will move. It won't extend over the step. That's new for ST8, that behavior. If I change it to model priority, of course, it will extend the step out. We don't want to do that. We just want to move that out, I don't know, 5 millimeters or so will do. Okay. A couple of other things that we might want to do here to modify is I just want to rotate those faces around the center here. And again, we're seeing with our design intent, as I rotate it, zoom in a little bit, it's picking up the symmetric faces, but I know that there's parallel faces out here that I want to pick up as well. So I go to Advanced. Now this brings up our traditional design intent menu, and we can turn on our parallel faces here, and we get the parallel faces. So at any time you have full access to the whole richness of the design environment. Let's make that 4 degrees will be adequate. A couple of other things that we've got that are new, just while I'm thinking about it. If I go into line drawing environment, let's just get a line so I can see what I'm doing. That will do. Lock onto here. And what I want to do is create something relative to the center. And if I wanted to make a line that was symmetric about the center, what I'd have to do is draw a line and then place some constraints on it. But if we look down the bottom prompt menu now, and if I press the S key, I will produce a symmetric line. Let's make that 8 millimeters long. And place that. I want to bring up something up here to, let's say, 80 degrees will be fine. And we're going to make a little cutout in here. Now, the beauty of Solid Edge again is we don't need to close the profile here. We will find the region. It's bounded by an edge curve there, and I can cut that out or project that up. I just want to cut it down to this area here. Now, another thing I might want to do is to create a line to create symmetry on the way through. So all I'm going to do here is to create a line again on the center. Just pick the center point here and use the symmetric key to draw my line. It's going to be symmetric, and in this case what I want to do is to just copy one of these holes down here. So we'll just copy that hole down onto this end like so, and copy again and copy that across to this end. Now when we get rid of the sketch, what we'll find is that the holes are symmetric, and they're symmetric not because of the sketch. They're symmetric because they are symmetric about the center of the part. Other things that we might want to do, if we select this hole here, we see it brings up aligned holes, so it will move those together. If I want to not have those acting as aligned, I can use a shortcut key, U for unaligned in this case, to turn that off. Turn it on again, and they all move together again. So you can see it gives you a great deal of flexibility, a great deal of power, and there's some new features in there that are going to make life quite easy. Just as a final note, if we want to select a great deal of geometry, just get a top view of this, and I want to pick up all my geometry on the inside there, I can turn off the design intent, because what I want to do is to rotate this. Okay, having selected all this geometry, we're going to place the steering wheel on the centre there to rotate it. I've turned off all the design intent, and all I'm doing is modifying those faces. Let's rotate them 45 degrees. And we can see that this gives us complete control over our part here. So with our Synchronous technology new design intent dialog box, it gives us a much simpler interface to the live rules. We still have access to all the richness of live rules, but it gets rid of the clutter, so it makes our design job much easier. The system's not getting in our road quite so much. The heads-up panel gives us the information that we need and no more information, and our geometry is a little bit more predictable when we're editing it. The big advantage for people coming into this is there's less time learning, more time designing. Complex sketching tools like helical curve and advanced polygon creation allow us to focus on our designs and not so much on the tool. Let's take a look. Here we have a soil sampler part that first of all needs to have a hex head applied here with the polygon sketching tool. In the past we had only one method of creating a polygon. Now we have a couple of options. This time I want to create a hex. Now I have the option of creating it either by the center, zoom in a little bit there, center of the edge, or by the vertex. We'll use the vertex in this case, so that we have the edges of the feature perfectly cover the edge. Now Solid Edge allows us to create complex features from simple sketches very simply. I'm going to use just our simple sketching tool here and define the plane on which we want to draw. Again, there's a number of planes in there. We use Quick Pick to find our base plane and lock to that, and I'm going to not draw yet. I'm going to draw into here, just create a line into here, an arc up from here to the .90 point, and just up here. Now Solid Edge allows us to have open profiles. I'm going to do a sweep here. I'm going to remove material and sweep it around this feature here. We can select the direction of the sweep, and I want to do a 360. And it very quickly produces the features that we want. Now let's take a look at the helix. As part of this new design, we need to create a complex helical feature that will be used to drill into the earth. To do that, we need to have a complex helical curve, which is now available under our surfacing tools. It's a very simple tool to drive. We simply give it the range, which is just down the center of the probe here, and some width. Now we do that fairly arbitrarily just to get the length, 135 millimeters, and the diameter is whatever comes up here, and we can change this. Now there's three types of curves that we can create. We can have a constant pitch, a variable pitch, and a compound. I'll just add, with a compound we can have a number of points at which the length, pitch and turns and diameter, etc. changes. Because we're using the method of length and pitch, our length and pitch is specified, and it works out the number of turns. I'm going to insert another two parameters in here. We're going to set the diameter here to 46. That's our first diameter at the bottom there. The next one is also 46. The last one happens to be, 8 millimeters at the top here. our length. The first one is 25. We can keep entering those. I know the pitch is going to be 10 all the way through, and I can add all of those. And you can see the preview updating there. But we can save these settings, and I've already done that for this Earth probe, and I've saved that, and we can see our lengths, our pitches. You notice the last one's greyed out because that's the length that we derive from the probe here. Okay, let's preview that curve, and it generates a curve. Now all we have to do with this curve is to create a sweep along it. We want to sweep a profile along there. So first we need to select our path, which is that curve. Check that off. Now I'm going to use a plane normal to curve to draw my... I'll set that back to 0 to make sure it's right on the end, and I'll draw a circle there right on the end, and that needs to be 3 millimeters to give us our wire diameter there. And we just return to our swept protrusion command, select the profile, and finish. And it generates our complex helix. Very nice. One more thing that we want to do here is just sharpen that off. Solid Edge provides us with a nice little tool to do that. We're going to do a chamfer with angle and setback. Pick the face, select that, pick the edge, select that, and it produces us a nice sharp edge. Now we've got as you can see, quite a complex feature here. And one of the beauties of Solid Edge is how easy these things are to edit. To edit this, I want to make it a little longer, for instance. All I have to do is pick the base feature that I used here, and we're going to increase the length of that by, I don't know, let's say 15 millimeters. There we go. You can see it move with the cursor. I can either drag it to a position or give it an accurate dimension. So when we return to our armadillo here, let's put the soil sampler on there. As we saw, the helical curve feature gives you the ability to create an almost infinitely variable helix. You can have constant, variable, compound, as we did then, and obviously it can be used to create other features such as sweep. As this example demonstrates, Solid Edge with synchronous technology along with intuitive and powerful design tools drives innovation and enables you to bring better products to market faster. Don't let your engineering software get in the way of your company's success. New in Solid Edge ST8 is the ability to create patterns via a table. In this case it's a spreadsheet. The spreadsheet contains the X and Y locations of the pattern instances along with a rotation angle, and it's relative to some key point or a coordinate system. Let's take a look. What we're doing here is creating some cutouts, cutouts and escutcheons for these joysticks. The joysticks are poking through from underneath, but we don't have the escutcheons there. So just let's have a look at the holes there. We've just got one hole, and we want to create some more. So just returning back quickly to our top view here, what we're going to do is fill in a spreadsheet with the locations of these of where we want the holes and the rotation angles. Excuse me, put the spreadsheet back. Okay, let's edit the spreadsheet. The first one is at -111. The angle there's 0. Now we're going over to the other side. The colours here are the same as the colours of the buttons too, just to make it a little clearer, hopefully. And I want to rotate this one 180 because there's a cutout in the hole. As you can see, these are a completely non-traditional pattern, and would be quite difficult to do in any other way. Okay, let's have a look at this this body front. Now, to create the pattern, basically the same way as we've done in the past, let's make that a little bit more upright. We just select the entities that we want to pattern. I think I got a bit much there. That will do. We go to our patterning tool, and you'll see the new one in here, pattern by table. Select the pattern by table. It's prompting us to fix the coordinate system, and we can change that to a key point if we need to later on, but this case we don't need to. And I'm going to pick up my joystick locations that we just created, open that spreadsheet, and it populates the table. But remember, we have to have a spreadsheet to be able to populate this table. Gives us a preview. We can close that and accept, and it builds the cutouts for us. And there we go. As you'll agree, this is a very powerful and simple feature to enhance patterning. As we turn on more parts, we notice that there's a button pad already present underneath the cover here. We've got one cutout already in the cover, but we notice there's an array of buttons, and some of them are angled. These also are driven by a spreadsheet, and we're going to use this same spreadsheet to edit our front cover here to bring in the cutouts. So the process is basically the same as it was before. We select the items that we want to include in the cutout. This means just get only that. That's what I want. To patterning, to our pattern command, our pattern by table. Again, we click on the coordinate system just to establish a plane, and I'm going to use a selected key point this time. I want the center point off this because everything's related to the center point of the button. And now we'll browse for our button locations, which is again a spreadsheet. So we'll open that, and if we just zoom out a little bit, we'll get a preview of how they're located. So let's accept that, and just quickly return to our top level assembly, and we see our buttons are the locations are all our cutout locations match our buttons perfectly, as we'd expect. Let's go back and make some edits to this pattern. If we look down here, we'll see our pattern. We can click on that, click on the pattern by table call out, and we have the ability to go and edit this table. So let's bring up the table. Here's our table. As I said before, this is just an indicator of what's in the spreadsheet. We want to edit the spreadsheet, so we can go into our spreadsheet. Just make that a little smaller. Now, what I've done here is I've already created some entries that I want to change to. Rather than watching me edit this table, you can just bear with me while I just delete the information I don't need. And here's the edits I want to make. I've removed some of the rows, changed some angles, done that sort of thing. So all we have to do is click on the save button just to save the table, and I'm going to update my pattern. And there's my new pattern. That's quite nice, but let's make some more changes to this. We can close out of the table here now and accept that. Let it build that, and just turn that off. So we're looking only at the pad here. If I just bring up the spreadsheet by itself, so I'm not in the pattern command at all, what I'm going to do is I'm going to insert some more information in here. So we want to add another key in here. So I'll build the location for that, 63. Remember, these are all relative to the, and I don't want any rotation on that, these are all relative to this first location here. So save the spreadsheet, and as if by magic we get our extra button come up here. Let's just go back and have a look at our overall. Well, our button pad no longer matches. So let's edit the button pad. All we have to do with that spreadsheet open, my spreadsheet's still open, it was hidden behind the screen here, it picks up the spreadsheet automatically and updates the button pad. And there it is, completed. So we can see this is a pretty powerful tool. This new functionality in ST8 allows us to create irregular and highly editable patterns of geometry from a simple spreadsheet. This enables you to design faster and more intelligently without constraints on your design process. Solid Edge continues to build on proven techniques that help our customers become more productive, and ST8 is no exception. Let's take a look at some of the assembly changes that have been made for ST8. Opening documents has always provided filters for the various document types. Here I'm looking for assemblies, but what I really want to find here is the top level assembly. I could search through and find it, but ST8 provides us with a tool to find the top level assembly documents straight away. Let's open this assembly. Sometimes when we open assemblies we'll find that there's parts or documents missing. ST8 has a very simple tool to allow us to rectify that situation. There, we've found the base. Solid Edge has always been a leader when it comes to being able to edit parts very easily and quickly, and ST8's no exception. In this case I'm going to modify the width of this part by using a key point off the existing geometry. And we've been able to do that for some time. I also want to be able to edit this part based on some existing geometry. Here I have a sketch from the assembly, from the upper level assembly, that I want to use as a cutout. We can select the edges of that sketch to provide a cutout tool, make it a cut, and cut down for some distance. There we go. It's very neat, and as you can see, an enormously effective and quick tool. I'm sure you'll agree with me that these tools will make a significant impact on your overall productivity. We've covered a lot of exciting enhancements today, and it's time to call a halt so we can have a question and answer session. Next week we'll continue this series with some changes to welding, a lot of changes in the digital mock-up area, which is about animations, IFC for BIM. That's a wonderful set of acronyms. It's Industry Foundation Class Files for Building Information Management. This is an area which many of our customers are becoming involved in, and I think you'll find quite exciting. And as always, Solid Edge enhances our drafting environment with every release. So we'll be looking at some new things in the draft environment and a new feature called Drawing Compare. So once again, thank you for your attention today, and we're now open for questions and answers. And as I said at the beginning, in your dialog box on the side of your screen, you can type in your questions, and the team will be standing by to answer them. Thank you for your attention.